So in the last video, we looked at we just introduced the quotient rule. And so we did this example in the way that we knew before, which was just to simplify this and then use the power rule several times. And then we went ahead and used the quotient rule and took the derivative of that function, and we got this, which you do not have to reduce, and I don't even want to try. But I wanted to show you guys in Desmos that those are the same. So I plotted both of those in Desmos. As you can see, the red and the blue functions here. You can actually see the red function. There it is. And then you can see that the blue one matches right up to it. So red is the way we would have done it with just the power rule. And then blue is the way that we can do it with the quotient rule. So you can see that they are the same, which is good. It's just an additional tool that we have that we can use. So let's keep going. Number 2 is not one that we could have done last week, but we can do it now. So this is f of x over g of x. And we're going to do y prime is low d high, so bottom times the derivative of the top minus the top times the derivative of the bottom, low d high minus high d low over ho ho or low low. So we will have bottom, so x cubed minus 3 times the derivative of the top, which is just 3. So ho d high, that's because this is the 1. The derivative of the top here, you do exponent down front and decrease it by 1. So it would just be 3 times x to the 0. So ho d high minus high, that top function, which is 3x minus 2, d ho times the derivative of the bottom. The bottom you have here, that 3 would go down front, reduce it by 1, so you have 3x squared minus 0 over the denominator squared, so x cubed minus 3 squared. Okay, so ho d high minus high d ho over ho, or g times f prime minus f times g prime over g times g. Okay, if we keep going, we have on this one, this is f on the top and g on the bottom. So y prime is going to be g of x times f prime of x, ho d high minus high d low, or ho over ho ho. Okay, so x cubed, that's g, x cubed minus 2x plus 1. We're looking at g of x times f prime. So we want to take the derivative of that. So that is a 1/2 times 2 times x to the negative 1/2. This is 2x to the 1/2. So exponent down front, decrease it by 1. Then, so that's ho d high minus high, so 2 times square root of x, d ho, so the derivative of the bottom. So this 3 is going to go down front, that becomes 3x squared. This 1 goes down front, so it's just minus 2, and then the derivative of 1 is 0. And then over the denominator squared. So x cubed minus 2x plus 1 squared. And I believe that that would be simplified enough for Hawks. You might have to do that, make 1/2 times 2 1, but I don't think so. Okay. So If we want to do some sort of application problems for that, we're given here that f of 2 is 3, f prime of 2 is -1, g of 2 is -11, and g prime of 2 is 6. We want to find the value of h prime for each of the following. So just stick to the rules here. What is the derivative of the product? So h prime of x would be first function times the derivative of the second plus the second times the derivative of the first. And that's true for any x. And if you want to know about h prime of 2, just replace all those input values with 2. And then go and find the information. So f of 2 is 3. G prime of 2 is 6. G of 2 is -11. And f prime of 2 is -1. So that's 3 times 6 is 18 plus 11 is 29. So just set it up with, don't let all of the information overwhelm you. Just set it up with the rules for how h is defined, how the derivative of h is defined, and go from there. And you can do basically the same thing with b. You have h prime of x would be g times f prime, so low d high, minus high d low over ho or low. And then again, if you're trying to put in a specific value for x, then just replace all of them at that step. So g of 2, f prime of 2 minus f of 2, g prime of 2 over g of 2 times g of 2. G of 2 is -11. F prime of 2 is -1. F of 2 is 3. G prime of 2 is 6. Using the stuff given to us in the problem. And then g of 2 is still -11. Okay. So this becomes 11 minus 18 over 121. -7 over 121. Okay. Okay. So, okay. If we are looking at number 2, we're going to find the equation of the tangent line. So that is the equation of we want the slope. That's going to be the derivative at that point. So we're going to end up using y minus y1 equals m times x minus x1. Remember, this is going to be the derivative at x equals whatever value. In this case, we're looking at x equals 0. Okay, so we are going to take the derivative f prime of x. This is going to be high, this is low. So high d low minus low d high over low. So trying to use low instead of post because that's how I learned it, but I can't do it. Low d high minus high d low over low. Okay, so 5 plus 2x, that's the bottom function, times the derivative of the top, which would be -3. Looking at this again, if power rule, exponent down front, that becomes -3. So low d high minus high d low, 5 plus 2x, the derivative of that is going to be just 2. Again, that's a power rule saying the derivative of 5 is 0. The derivative of 2x is just 2. This is what you learned last week. Then the denominator squared, so 5 plus 2x squared. This is f prime of x everywhere. We want to know m is going to be f prime of 0, right? We're trying to look for the derivative at 0. So we want to know f prime of 0. So go ahead and plug in 0. This would be 5 plus 0 minus, or times -3, minus 2 minus 0 times 2 over 5 plus 0 squared. So 5 times -3 is -15, minus 2 times 2 is 4 over 25. -19 over 25. Okay. So then if this is m, and we're going to use this up here, go back up here. This is, let me use a different color. This is x1 and y1. So we would have y minus 0.4 equals m, which is -19 over 25. I don't have a calculator handy, or I would put that in a decimal to make all of this match. That's 0.76 maybe, times x minus 0, x minus x1, which is 0. Again, that's from this ordered pair. Y minus 0.4 equals, I believe this is 0.76 x, and then distributing this gives you 0. So that would be your answer. The equation of a tangent line at a point, you're going to find the derivative at that point. And that's the slope of the line, and then use the ordered pair there for the y1 and y2, or the x1 and y1 in your point slope form. Okay, so we did this in chapter 2, which is now we have a function that we couldn't have done it with then. Okay, the demand for a particular item is given by this 115 over 3x plus 1. Find marginal revenue. So again, looking at this, marginal revenue tells you you're going to take a derivative. Revenue is going to be x times the demand. So that's going to be x times 115, x times 115 over 3x plus 1. And you can multiply straight across here, so you get 115x over 3x plus 1. When you multiply fractions, a over b times c over d, you just multiply straight across. That's ac over bd. And so you're going to do a similar thing here. That x is just going to go on the top. So 115x over 3x plus 1. Okay, so marginal revenue, we're going to take the derivative. So we want to know r prime of x. This is going to be high and ho here. So this would be ho d high minus high d ho over ho ho. So then use your derivative skills now. So 3x plus 1 at the bottom times the derivative of the top, which would just be 115, because this is x to the first, minus the top, so 115x, times the derivative of the bottom, which would just be 3, over the denominator squared, 3x plus 1 quantity squared. And then if you want to know the marginal revenue when x is 3, you're going to do r prime of 3 and just plug in the 3, use a calculator or Desmos to do this. What, 10? 3 times 3 is 9, plus 1 is 10, times 115, minus 115 times 3 over 10 squared. And I believe That's 115 over 100, is that right? Which is 1.15. Okay. So there's your marginal revenue when X is 3. Figure out what the marginal revenue function is and then plug in the value 3. Okay. Lastly, number 4, the profit from the sale of X items is given by P of X equals 2 minus 0.5X times 0.5X minus 5, where P of X is in hundreds of dollars and X is between 2 and 10. Find the marginal profit when X equals 5. So again, we see the words marginal. This tells us take a derivative, and we have a profit function, so that's good. So what we could end up doing is foiling this and then using the power rule, or we can use the product rule to take that derivative. So P prime of X is going to be, this is F of X, and this is G of X. So first function times the derivative of the second plus the second times the derivative of the first. So first function is 2 minus 0.5x times the derivative of the second. That would just be 0.5. This is an x to the first. Exponent on front decreases by 1. Plus second function, 0.5x minus 5 times the derivative of the first. This time it's negative 0.5. Looking at this, is the power of 1, put it down front, and then decrease it to 0. So that's P prime of X for all X. Sorry, that derivative is nuts. Okay. And then to figure out when X equals 5, you would plug in 5. So the calculator. This is a lot of 5s. 2 minus. I'm going to go with what I wrote down is that this is 1. 5 times 5 is 0.25. 2 minus 1.75 times 0.5. Okay, I think that's good. Okay. I'm sorry, I'm bothered by this. I'm gonna plug it in and make sure this is right. Let's see. Two minus 0.5 times 5 times 0.5 plus 0.5 times 5 minus 5 times negative 0.5. Okay, it is 1. Alrighty. If you guys have any questions, please let me know.